So the regular polyhedra, which is the sort of geometric term for the 5 platonic solids, regular being, all the same sides. So there's a bunch of different facts about these. Every internal angle is the same. Every side is the same length. Every face is the same shape, right? And so that's that word regular. And then they're polyhedra, right? They enclose volume. They are a system. There's an inside and an outside. So the regular polyhedra provide a good starting point from which to branch out in all directions. So now we're gonna meet the 18th century mathematician Leonhard Euler. He lived 1707 to 1783, and he greatly simplified this task with the realization that all patterns can be broken down into 3 elements. There's that number 3 again. We've got crossings, which are junctures, nodal points. We have crossings, lines, and open areas, basically, right? We've got the angles, the lines, and the faces. And he thereby introduced the basic elements of structure, vertices, edges, and faces, which underlie all geometrical analysis. And Buckminster Fuller saw this contribution as a breakthrough of equal importance to the law for which Euler is most famously known. And we're going to talk about that right now. So this is Euler's law. Getting a little technical here. Just to be clear, I'm not a big math guy. I was an English major. This is as basic as we can possibly make it. So Euler's law states that the number of vertices plus the number of faces in every system will always equal the number of edges plus the number 2. Any geometrical structure, any shape, any system abides by this formula. It's kind of amazing. And so we can test it using our regular polyhedra, and sure enough, it works out just perfectly. So we can study this, but it's arithmetic right in front of us. And so the mystery of this law is the number 2. To have a whole number constant in a formula like this that defines every single geometric structure possible, where does V plus F equals E, but then there's just the number 2? What is that doing there? And why does it work every single time? And so Buckminster Fuller says that the recurring 2 represents what he calls the poles of spinnability, which, if you study Fuller, his language is so ridiculous and playful. He's basically, there should be a Fuller dictionary, because he was so obsessed with precision that he was very much against the phrases sunset and sunrise, because that's not physically what's happening. And he says that confuses us, where it's actually, the sun isn't rising, the earth is spinning. And so we should come up with a different vocabulary word to make us aware that when the sun is rising, it's actually not that, it's earth clips or something. He had his choice of words didn't actually work, but I like the attitude behind it. So anyway, here we have the poles of spinnability. And he says all systems can be spun around a central axis. An axis has 2 poles, north and south pole. And thus at any given time, 2 vertices must be poles. So if you subtract the 2 poles from the total number of vertices, you get a number exactly equal to the combined number of edges and faces. So basically what that number 2 does is it's giving us the polarity. It's giving us, we talked about how that number 2, the paired opposites, are this necessary tension for any subsequent creation to happen. So it would make sense that the defining formula of the shape of space includes some measure of polarity. And so that's what that number 2 is doing there. It's showing us those pairs of opposites. Okay, those are our Platonic solids. Follow? That makes sense? How are we doing? Yeah, okay. So with those pairs of opposites being encoded into every aspect of existence, it would make sense that our Platonic solids themselves abide by the concept of the pairs of opposites. And so indeed, this is what we have here. So this is one of the remarkable qualities of these solids, is that the octahedron and the cube are the inverse of each other. And they're sort of infinitely recursive, right? So if we look at this cube, and all you have to do is put a dot at the center of each face, right? So very similar, same function we were doing, we're moving circles to the center dot, we're moving the triangles to the center dot, and then let's just put a dot at the center of things, which is, again, dimension 0, right? Dimension 0 is the dot at the center of everything. And in reality, no matter how accurately you measure the center of something, you can never actually get to the because you can always make a smaller dot that's more at the center. And this is, there's a famous, what is his name? He's like a Greek geometric mathematician who, no, it wasn't Pythagoras, it was Zeno. His name's Zeno. It's Zeno's paradox, whereas he says you can never actually arrive anywhere because you could always go half a distance again, half a distance again, half a distance again, half a distance again. And so geometrically, you can never actually arrive anywhere. And so, yeah, this is Zeno's paradox. It's an amazing thought experiment, and just emphasizes that it's about the journey, not the destination, which is good for a course like this because it may seem interminable, and it's about the journey here. So okay. Anyway, a dot at the center of each face of the square, and then you just connect those dots. And what does that give us? It gives us our perfect octahedron. And then let's try the same exercise with an octahedron. Just put a dot at the center of each equilateral triangle, connect those dots, and what do you have but a cube? And so there's this intimate interrelationship between the octahedron and the cube. Let's try it with our other solids. Let's try it with the icosahedron. Just put a dot at the center of each triangle, and what does that give us but the dodecahedron with all of the pentagons inside. And same inverse relationship. Take the dodecahedron, put a dot at the center of each of those pentagons, connect all those dots, icosahedron. And so when we're talking about like nested spheres, the infinitely recursive out and all the way down. If you've got a dodecahedron, you can make an icosahedron that's bigger than it and inside it. And then you can go out, 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 in infinitely. And so then we've got our tetrahedron, our first, the tetrahedron is unique, right? So we've got 2 pairs, but we've got 5 Platonic solids. What are we going to do about that? But the tetrahedron has these special qualities, being the most efficient. It is our minimum 3-dimensional structure. And so if you do the same exercise and put a dot at the center of each of those triangles, you get another tetrahedron. The tetrahedron is its own opposite. If it is infinitely recursive on its own account, right? And it's an inverted tetrahedron, but it just flips back and forth, on and off, on and off, on and off, in and out, infinitely. So this is, again, polarity is the primary tension that allows that it's the tension on the guitar string of the first dimension that sets all this creation in motion anyway. And then we take our 2-dimensional structures and start piecing them together into these 5 and only 5 three-dimensional structures. And so at every level of creation, the previous dimension is encoded into it, right? So because at each one of these, there's a center dot that, again, you can zoom in infinitely and never get there, and there's a sphere containing it, which is still the dot, which you can zoom all the way out and never get to the edge of it, right? And then there's the polar opposites, which either you're spinning or you're getting these paired opposite structures. And then, of course, the two-dimensional shapes are what actually construct the 3 dimensions to begin with, right? So this is what we're talking about when I say multidimensional. These are the dimensions. This is how this works, where at each subsequent layer, every dimension is encoded, and they're just a set of nested spheres, and you can then, with that awareness, choose which layer you're working with. Choose, am I going to be 3-dimensional, or sometimes it's actually appropriate to adopt your 1-dimensional attention, right? Last night, I had a lot of work to do to prepare my slides. I needed some 1-dimensional attention, laser focused into this. Whereas sometimes it's better to be 3-dimensional, and I want to be able to have eyes in the back of my head and see in every direction and be up and down as well as horizontal, right? So yeah. This is what we're talking about with the multiple dimensions. Questions, comments, confusion, enthusiasm? Hillary has a question.
It's more like a aha comment of this, understanding these concepts and being able to understand where you are in the polarity of it. If you are being too one-dimensional or too laser focused, or for me, for example, most of my life has been way more fluid, and I'm really having to learn that linear laser focus to bring balance to my life. So it's medicinal,
Yeah,
it's
it is
medicinal shapes.
Medicinal shapes, and this is exactly it. And this is multidimensional medicine, and exactly how to use these shapes medicinally is the topic of the multidimensional energy management course, which is forthcoming, and if you're watching the recording, available elsewhere. Yeah, because there are this is powerful information. This is the structure of reality. This is built into you. This is built into the whole world, atomic structure, galactic structures, which is where we're going next in part 4. And so to be able to work with it and use it skillfully is the medicine here. So yeah, spot on. Love that aha for you, for us. Everybody else all good?
My brain feels a little broken, but in a good way.
Broken in a good way. Yeah, totally. Well, luckily, it breaks and then comes back together, right? And is restructured in a harmonic geometric way, hopefully. So, okay, let's conclude part 3 on platonic solids and move along to part 4, energetic architecture.